Hi everyone, this is Michal from Airhead, and today we'll go over the meteorology ATPL subject, and more specifically, we'll go through the most recent questions seen in the actual EASA exams from the meteorological information topics. So let's jump into these questions. We'll talk about TAFs, METARs, and we'll see a couple examples of questions, including annexes and specifically the maths. And this is the case for the first question for today, where we have to see the appropriate temperature deviation at this time at flight level 50 over the mid-Atlantic, and we'll see the boxed section in the annex right here. So first of all, we just cross-check the chart. On the left upper side, you can always see the validity of the chart and the altitude that is issued for, and these will be usually issued by the competent meteorological station for an appropriate level. So this also can be used for your flight planning purposes, and mainly will be used actually for flight planning purposes and to see where the freezing levels are. However, going back to the question, we have flight level 50, which is this is a pressure altitude of 5,000 feet. And we can see that at this altitude in the boxed section, the temperature is 7 and the wind is blowing with intensity of around 45 knots, if I can see this properly. So we know that the temperature is 7. EASA temperature approximately decreases by 2 degrees per every 1,000 feet. Of course, starting from 15 degrees at sea level. That means that at 5,000 feet, the temperature should be plus 5 degrees in EASA conditions. However, here is 7. That means that the temperature at the moment is 2 degrees plus EASA, as the EASA temperature at level 050 would be 5 degrees. And that's really it. This is a very easy question, easy points. However, don't get caught up with such questions. As you can see, it takes around 10 to 20 seconds to answer these and move on. For question number 2, a METAR message is valid for how long? And this is a tricky question because, of course, the METARs can be issued at different time intervals depending on the airport. Most usually this will be 30 or 20 minutes, sometimes 15 and sometimes 40, depends on the station. However, they're published every 30 or 20 minutes. However, remember that METARs are meteorological aerodrome reports, so they report what is happening at the airport at this very moment. They're not forecasts, they are reports of the current situation at the airport. So if a METAR is reported at a certain time, this means that the weather that's in the METAR was seen at this particular time. And for example, we had the visibility of 2,000 feet and we had the wind blowing at a certain direction at that particular time. And this means that this METAR actually is valid only at the time of publication. Of course, if you open charts and you open METAR reports from different airports, you can see some trends, you can see the general gist of what the weather will be like in the nearest future. However, the report is strictly the one that has been observed at the time of the issuance of such message. The difference will be it will be different for TAFs, which are terminal aerodrome forecasts that will forecast the weather for specific periods, and then you'll know that this is the weather that will be expected in, for example, in 2, 3, or 4 hours. However, METARs are only valid and they're only true at the time of publication. Of course, you can use them more freely because they give you the general sense of what the weather is like. However, remember that the METAR shows you the actual weather at the moment of publication. Question number 3. According to the chart, which of the following weather phenomena can be encountered at flight level 120 over northwest corner of Spain? So let's take a look at this annex, and I'll just tell you as a bonus, if you go to the London WAFC, then you can see that these significant weather charts have actually changed. These are still used in the actual EASA exams. However, the current ones are a bit more colorful, and now the London weather authorities have changed it slightly so that there are more colors and there are some more sections. It's a bit easier to read. However, these are required by the examiners in EASA, and this is what you'll see in your current exams. So looking at northwest from Spain, you can see this elongated part which shows some significant weather. And to decipher what significant weather is in this section, you basically look at the box that is pointing towards it. So you can see the box that's pointing towards it. I will underline it here, is this one right there. And also something to remember is that this axis right here, so you have two symbols, one for moderate turbulence and the one below it for moderate icing. And you have the altitudes, which is 220 xxx, 180 xxx. So what does this xxx means? And there are some questions asking about exactly this. So the xx means that these phenomena can be expected below the level that chart is reporting. So it doesn't say from the ground level, it doesn't say from the level that chart starts. This particular chart you can see in the left upper corner, or underline it again here. So right above the line that I just drew, you have flight level 100 to 450. This means that whatever is at the X, that means that this phenomena can be expected below flight level 100 as well. We don't know how much, but this is something to remember. The X's don't mean ground level or flight level 100. It means below the level in the chart. So we can see that we can expect here moderate turbulence and moderate icing exactly in the level we're flying, which is 1 to 0 for this question. And also just something interesting for you to remember. The H here means the highest level of the troposphere. So this is where the tropopause starts. There's also usually an L indicating the lowest height of the troposphere on the chart right here, and for the general area. So this is just something to keep in mind. So here we will expect moderate icing and moderate turbulence. Moderate icing is in the answer. For question number 4, which of the following positions represents a non-frontal depression? So what is a non-frontal depression? So there are two types of depressions. You have a frontal one, of course, and a non-frontal depression, which most often will be a thermal depression, so a depression associated, or a low pressure zone associated with hot air moving upwards, creating a low pressure zone. And especially in Europe, these non-frontal depressions should be associated with some adverse weather conditions, and more specifically, thunderstorms. So if we look at the annex, you can see there's a lot happening. And the numbers for questions, let's see, PW, Victor, and Romeo. So you have P here, this is 1030. This is a high pressure area compared to other places. V and W. So this is the W is, of course, see, it's associated with front. We have an occlusion that will also indicate some embedded thunderstorms. So this is something to always watch out for. However, this is clearly a frontal phenomenon and frontal low. We have Victor, which is also very close to a high right in front of the cold front moving. And then Romeo to the right. You can see that this is the only answer, and that's relatively away from any fronts. However, this one, it's not very low. I will say here is that for sure. So this is a question that's slightly tricky, but this is why you always have to exclude the answers first. And then as you can see, we're only left with Romeo, which could be also an orographic low, which is also type of a non-frontal depression. Around you have 1028, 1024. So this is clearly a some form of a lower pressure zone, because the other ones are all associated with a front. However, I can see how this can be tricky, so always try to exclude the other answers before committing for one. Now going into the METAR message. So the METAR for your destination reads as follows. We have the airport code Echo Golf Uniform Bravo, and this one is issued at the 28th day of the month at 9:50 Zulu time. We have the wind blowing from 50 degrees with a speed of 90 knots. The visibility is 10 kilometers or more. We have broken clouds at 3,200, which are towering cumulonimbus clouds. The temperature -3, dew point -9, with the QNH 1003. And there is a tempo trend message, which essentially says that for the next 2 hours, we can expect very intensive showers of snow and decreased visibility to 1000. However, what does the tempo mean? This is something to remember. Tempo in a trend METAR message means that for the next 2 hours, but no more for half of the 2 hours at a time. For no more for half of the tempo, meaning no more for 1 hour and no more for 1 hour at a time. We can expect this. If you will see a tempo message in a TAF, there will be a time period from between, for example, between 10 and 14. In that case, the tempo message will mean that the occurrence will happen for no more than 2 hours, so half of the tempo, but no more than 1 hour at a time. And that's what it means. The plus signifies intense, and a minus would be less intense occurrence. So here, the only one that talks about during the next 2 hours, heavy snow showers lasting less than 1 hour in total. Yes, so as I said, they have to be no more than half of the duration of the tempo and no more than 1 hour at a time. In metas, the tempo will be 2 hours. However, in toughs, they can be much longer. Something to remember also is a becoming, which will indicate a permanent change in weather in the forecasted period, and then the change will continue to exist. So that's the difference between becoming. Tempo is just temporarily. Becoming means a permanent change of weather. Question number 6. Also, we need to read the tough mess and the METAR messages. So later in the day, which of the following airports is expected to experience improved visibility? So as you can see, we have 4 different METARs for 4 different airports issued on the 19th of the month at 10:50 Zulu. Of course, then we have the wind, and then we have the reported visibility. Everywhere we have 3,000, 4,000, 3,000, and 4,000 again, with followed by the temperature. At the last METAR, you can see the designator BR or Bravo Romeo. This means a mist, and don't forget that a mist is a phenomenon where the visibility drops to below 1,000 to 5,000. Anything below 1,000 will be classified as fog. So now, which one shows increased visibility? So on the first message, you can see that there is a becoming 8,000 meters visibility. So of course, first you can see the correct message is exactly this one, or the correct answer, because the visibility will increase from 3,000 meters all the way to 8,000. The only trick here is no sig means no significant change. So this means this will be continued. Becoming 1,000 here in the last one, the visibility will actually decrease rather than improve. And for the last one, for the second one, the NSC means no significant cloud. So that means that if there were some clouds at the time, NSC means that there are no clouds below 5,000 feet. Or no cumulonimbus or tau-cumulonimbus reported. So this is like a little baby of a cavucate, but just regarding the clouds. However, this does not necessarily mean that the visibility will increase. If the visibility was increasing significantly, then we would see becoming cavucate, meaning the visibility would be over 10 kilometers. However, for this one, the first answer is correct. Echo Golf Lima Foxtrot. And for the last question that we have for today, where we just need to read a terminal aerodrome forecast message and say which weather is most likely to be experienced at 15 UTC. So we have the stuff for this particular airport issued on the 21st at 12 Zulu. And then we can read what exactly is happening there between 13 and 22 Zulu of the same day. So basically, it's a tough message for 9 hours. So between 13 and 22, on the 21st day of the month, we can see that the wind is 220 degrees at 18 knots, gusting 35. Visibility is 10,000 with scattered clouds, broken clouds at 3,000. And we have a becoming, so between 13 and 15, we'll have a change in the wind. So the wind will start gusting up to 45 knots, which is very high. However, this becoming is only changing the wind. So only the wind will change for that particular time. We have a tempo message as well. So temporarily between 17 and 20, meaning for 3 hours, we'll have a visibility of 4,000 feet with intense showering rains and some changing clouds. And then at the end of the day, so between 20 and 22 UTC will have a bit of a lowered wind. And also you have the TX and TN messages at the end. TX means a maximum temperature that can be seen at that time, particularly at 15 Zulu, and the minimum temperature that day, which will be 14 degrees at 21 Zulu. So now looking at all the possible answers at 15 UTC. So first thing that pops into your head is the temperature. Of course, 15 Zulu, we're expecting 18 degrees. So If any answer shows 18 degrees, can be very probable to be the correct one. And as you can see right here, temperature 18 and 18 on two possible answers. So let's just look at them and go through. Visibility 4,000 meters and gusts up to 25 knots. So 4,000 meters is right here. However, this is a tempo message from 17 to 20. So not necessarily. There is no change in the origin from the original TAF. So all the becoming and tempo trends are not changing the visibility from the one that was given initially. So this is the initial and primary TAF. I just underlined it here. Everything else is then a change or kind of trend. So the visibility will continue to be 10,000 feet plus, making the last one probably right. So visibility is 10 kilometers or more. Ceiling, which is broken or overcast, we have broken 3,000 feet. Wind, we have 250 degrees, which is true. It's right here because there is a becoming from 13 to 15. So that means that at the end of this time period, the weather will permanently change to this from the initial one, making all the correct answers from this question right here, making the answer delta or the fourth answer correct. Thank you very much. I hope you enjoyed it, and I wish you all the best with your studies, and I hope to see you in the next video. Have a great day, and bye-bye.